Compression fittings are used in plumbing and electrical conduit systems to join two tubes or thin-walled pipes together. In instances where two pipes made of dissimilar materials are to be joined, the fittings will also be made of one or more compatible materials appropriate for the connection. Compression fittings for attaching tubing commonly have ferrules in them. Compression fittings are also used extensively for hot and cold water faucets and toilet stop valves. Compression fittings are well suited to this application, as these valves are usually located in confined spaces where copper pipe would be difficult to solder without creating a fire hazard. Compression fittings are the industry standard for chemical, oil and gas, R&D, biotech, and the semiconductor industry. They are used due to their ability to provide leak-tight seals. These fittings can be remade. How they work: in small sizes, the compression fitting is composed of an outer compression nut and an inner compression ring or ferrule that is typically made of brass or copper. Ferrules vary in shape and material but are most commonly in the shape of a ring with beveled edges. To work properly, the ferrule must be oriented correctly. Usually the ferrule is fitted such that the longest sloping face of the ferrule faces away from the nut. When the nut is tightened, the ferrule is compressed between the nut and the receiving fitting. The ends of the ferrule are clamped around the pipe, and the middle of the ferrule bows away from the pipe, making the ferrule effectively thicker. The result is that the ferrule seals the space between the pipe, nut, and receiving fitting, thereby forming a tight joint. Larger sizes of compression fitting do not have a single nut to compress the ferrule but a flange with a ring of bolts that performs this task. The bolts have to be tightened down evenly. Thread sealants such as joint compound are unnecessary on compression fitting threads, as it is not the thread that seals the joint but rather the compression of the ferrule between the nut and pipe. However, a small amount of plumber's grease or light oil applied to the threads will provide lubrication to help ensure a smooth, consistent tightening of the compression nut. It is critical to avoid over-tightening the nut or else the integrity of the compression fitting will be compromised by the excessive force. If the nut is over-tightened, the ferrule will deform improperly, causing the joint to fail. Indeed, over-tightening is the most common cause of leaks in compression fittings. A good rule of thumb is to tighten the nut first by hand until it is too difficult to continue and then tighten the nut 1/2 turn more with the aid of a wrench. The actual amount varies with the size of the fitting, as a larger one requires less tightening. The fitting is then tested. If slight weeping is observed, the fitting is gradually tightened until the weeping stops. The integrity of the compression fitting is determined by the ferrule, which is easily prone to damage. Thus care should be taken to when handling and tightening the fitting, although if the ferrule is damaged it is easily replaced. In a bind, master plumbers have been known to replicate the sealing action of a ferrule by using an artfully woven piece of thread seal tape. This is attempted as a temporary solution to prevent a leak until a proper ferrule can be procured. Types of fittings: there are two traditional types of compression fitting, standard and flare fittings. Standard fittings require no modifications to the tubing. Flare fittings require modification of the tubing with a special tool. Standard fittings are typically used for water and compressed air connections, whereas flare fittings are used for gas and high-pressure lines. A standard fitting can be installed using an ordinary wrench to tighten the surrounding nut. To remove it, a specialized puller is often used to slide the nut and ferrule off the tube. If the ferrule is difficult to remove, it can be weakened with a cut, care being taken to not nick the pipe while cutting. A newer type is push-in compression fittings. These fit over the end of a tube using a grip ring to hold the sides of the tube and an O-ring to form a seal at the end. Advantages: compression fittings are popular because they do not require soldering, so they are comparatively quick and easy to use. They require no special tools or skills to operate. They work at higher pressures and with toxic gases. Compression fittings are especially useful in installations that may require occasional disassembly or partial removal for maintenance, etc., since these joints can be broken and remade without affecting the integrity of the joint. They are also used in situations where a heat source, in particular a soldering torch, is prohibited, or where it is difficult to remove remains of water from inside the pipe which prevent the pipe heating up to allow soldering. Disadvantages: Compression fittings are not as robust as soldered fittings. They are typically used in applications where the fitting will not be disturbed and not subjected to flexing or bending. A soldered joint is highly tolerant of flexing and bending. Compression fittings are much more sensitive to these type of dynamic stresses. They are also bulkier, and may be considered less aesthetically pleasing than a neatly soldered joint. See also, AN thread, flare fitting, JIC fitting. Notes and references. External links, jointing copper tubes, compression joints. UK Copper Board.